Okay, as we continue along with this unit of trigonometry, uh, not only do we have right triangles, it looks like today we're going to have special right triangles. So let's discover exactly what a special right triangle is. There are actually two of them, all right? Two triangles that we need to actually memorize. First one is the 45-45-90. Right? It has to have a 90-degree angle or it's not a right triangle. The other two angles must add up to 90. And how about this? They're identical. They're both 45 degrees. Now, of course, since the acute angles are both 45 degrees, the legs have to have the same length, right? So they are congruent. If the angles are congruent, the legs have to be congruent. If the angles have equal measurement, the legs have to have equal measurement. And the hypotenuse is always square root 2 times a leg. Right? So on the special triangles, when there are two equal sides, I use root 2. Right? 2 goes with 2. Two equal sides, use root 2. So let's see if this root 2 trick works on a different triangle. Okay, now if I call one of the legs to have a length of 6, well, since 45 degrees equals 45 degrees, if one leg is 6, the other leg must also have a length of 6. Now, our special trick says that the hypotenuse should be 6 root 2. Let's see if it is 6 root 2. A squared plus b squared is c squared. I can plug in the values for the legs. Take the square root of 72. Oh my goodness, what is the square root of 72? 36 is the largest perfect square. That will factor out of that. And holy cow, it really is 6 root 2. So if one leg is 6, the other leg must be 6. And the hypotenuse is simply 6 root 2. Can I do this for any triangle? Any 45-45-90 triangle? Well, what should we call one of the legs? Well, if it's supposed to be any triangle, you know what number I have to assign? X. Right? If it can be any length, I've got to use the variable x, which means the other leg must also be x. Okay, is the hypotenuse really x times the square root of 2? Let's find out. We got to find the hypotenuse. A squared plus b squared equals c squared. Well, a has to be x, b has to be x. It looks like I've got 2x squared. Well, I don't want c squared, I want c. We better take the square root. So I've got a square root of x squared, but I've also got a square root of 2. So I've got x times the square root of 2. Sure enough, whatever one of the legs is equal to, the other leg has to be the same. And the hypotenuse, just multiply it by root 2 and you got it. The other special right triangle that we really need to memorize is the 30-60-90 triangle. Right? You'll notice that we've got legs are different sizes, right? We got the very shortest side, the shorter of the two legs. Because it is the shortest side, it must be opposite the smallest angle. Then we've got the longer of the two legs, right? It's kind of like the medium-sized side, right? If there's 3 sides, it's the middle one in length. It has to be across from the 60-degree angle. And it is almost root 3 times the shorter leg. So if I know the short leg, I multiply by root 3 and I get the long leg. And the hypotenuse is always exactly 2 times the shorter leg. Notice the comparisons are always with the shorter leg. I don't have a direct comparison from the long leg to the hypotenuse. We'll do a few examples in a moment. Now, of course, when two sides were the same, I used root 2. Right? I went 2 and 2. Here, there are 3 different lengths. If there's 3 different lengths, I got to remember that the root 3 is going to show up. Just make note that the root 3 is not the hypotenuse, however. Right? 2 equal sides, root 2. 3 different sides, root 3. So I know which triangle is which. Now, how do we show that this is true for any length? Well, we actually start with our equilateral triangle, right? Each angle in our equilateral triangle is 60 degrees. Notice that I decided that I'll use 2x as the measurement of one side. And if you're trying to figure out, well, why would you use 2x? Remember, the hypotenuse is going to be twice as long as the short leg, right? This will make the math easier if I have 2x. So I'm going to whip out a chainsaw and cut through this, right? Or I'll just construct an altitude, also known as a perpendicular bisector. And I will cut that triangle exactly in half. So notice that one of the 60-degree angles is still intact, but one of those 60-degree angles is now cut in half, so it's only 30 degrees. And because it's a perpendicular bisector, I've got a 90-degree angle there. So it's a 30, 60, 90 triangle. Notice across from the 30 degrees, that length is now just x because it got cut in half. So sure enough, the hypotenuse must be twice the shorter leg. Now, is it other leg, the longer leg, across from the 60 degrees, is it really x times root 3? Well, we're going to have to find out. Let's find the length of that longer leg. A squared plus b squared equals c squared. A squared plus x squared equals 2x quantity squared. Of course, 2 times 2 is 4. X times x is x squared. So a squared, well, if I subtract x squared from each side, a squared is 3x squared, which means a will have to be the square root of 3x squared. Square root of 3 I'm going to be stuck with, but the square root of x squared is x. Sure enough, if the short leg is x, the hypotenuse has to be 2 times x. If the short leg is 3, the longer leg has to be x times the square root of 3. Again, our super duper reminders: capital letters for the angles, lowercase letters are going to be for the sides, and the corresponding sides have to be opposite their angles. And I will always use C for the right angle and lowercase c for the hypotenuse. You're not required to, but I always do so we avoid confusion. Okay, so let's do some examples. Find the missing sides of each triangle. Well, I know side A is 12, right? Because that's an opposite angle A. Which one do we want to find? Well, hypotenuse is easy. I just double the short leg. 12 times 2 is 24. How do I find the longer leg? Well, I multiply it by root 3. There I go. Those are the 3 sides of that triangle. Ooh, this time I know side B. I don't have a shortcut to go from the long leg to the hypotenuse, but I do have a shortcut to go from a long leg to short leg. Instead of multiplying by the square root of 3, I will divide by the square root of 3. So the shorter leg is just 8. Hypotenuse, piece of cake. Let's multiply it by 2. 16. Now we've got all 3 sides. Okay, I know the hypotenuse is 18, so that's where we start. The shorter leg has to be half of that amount. So if I divide by 2, I get 9. The longer leg, piece of cake, multiply it by square root of 3. And now we've got all 3 sides of that triangle. Okay, we know the longer leg is 6. Let's divide by square root of 3 to get the shorter leg. Of course, we never leave a radical denominator, so let's multiply by the number 1. Disguising the number 1, of course, as square root of 3 over square root of 3. And then this is why we all took first year algebra. Although some of that might actually even just be pre-algebra because we don't have a variable in there, right? You're just doing some computation. 2 times the square root of 3 is the shorter leg. And of course, if I know the short leg and I want the hypotenuse, I just multiply by 2. And so 4 root 3 is the hypotenuse. Do 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 do. Okay, let's look at 45, 45, 90 triangles. I know side A is 6. I know the legs have to be equal to each other in length, so side B has to be 6. And if I want the hypotenuse, I multiply by root 2. Hypotenuse is 6 root 2. And we've got it. Ooh, I'm starting with the hypotenuse. I have to divide by square root of 2 to get one of the legs. I divide by square root of 2, I just get 5. Of course, the other leg also has to be 5. And I've got all 3 sides. Ooh, I've got the hypotenuse is 14. Let's divide by the square root of 2. Again, mathematicians do not leave radical denominators. So again, we multiply by the number 1. We disguise the number 1 as square root of 2 over square root of 2. In the denominator, well, square root of 4 is equally just plain old 2. 14, of course, is 7 times 2. And we can cancel out the 2 in the numerator with the 2 in the denominator. 7 root 2 is one of the legs. So the other leg must also be 7 root 2. Oh, oh. Can our happy, smiley face solve the maze and see what's in here? Oh, he's getting some positive encouragement here. Oh, the more success we have, the more positive reinforcement. Ooh, it looks like there's going to be an IXL today. And that IXL is slowly showing up as we're making our way through this maze. Looks like the IXL will be Q4. Oh, come on, smiley face, you can do it. You're getting all those approvals you go through. Oh, come on, you can do it. Oh, he's going to the worksheet. He's going to the worksheet. There's a worksheet showing up. Oh, and our smiley face has successfully made it to the worksheet. And the IXL will be on the special right triangles, which is what we just introduced today. And one of those yellowish looking things, I don't know if it's a smiley face, but it sure is a happy looking creature.